Welcome to The Explainer. We're going to talk about something wild today. What if our universe came with a hidden operating manual? I'm serious. There's a radical new theory out there that claims it's found exactly that. A set of instructions that could literally rewrite our understanding of, well, everything.
Okay, let's start with a really provocative idea. You know how we think 95% of the universe is missing? Dark matter, dark energy, all that stuff? Well, what if it's not missing at all? What if it's not even stuff? What if it's just a glitch in time?
Okay, so to really get what this new theory is all about, we have to talk about the huge problem it's trying to fix. And trust me, it's a big one. For decades now, cosmology has been stuck in this quiet crisis, this mystery of the dark universe.
So our standard model of the universe, it's kind of humbling when you think about it. Look at this chart. Everything we can actually see and touch, every star, every galaxy, you, me, everything, that's just 5% of the cosmos, a tiny sliver. The other 95%, it's a total mystery. We've given it names, sure, dark matter and dark energy, but we have no idea what they actually are.
And believe me, it's not because we haven't been looking. We've built these enormous detectors deep underground. We've smashed particles together at unbelievable speeds, all of it to find these weird, exotic particles that could explain this missing 95%. And the result? Nothing. Zilch. Nada. The search has come up completely empty. And that's got some physicists asking, hey, maybe we're looking in the wrong place entirely.
And that's where this new idea comes in. It's called the Unified Chronofractal Field theory, or UCF for short. And its starting point is totally radical. It says we need to completely rethink what time is.
At the heart of the whole theory is this one simple but profound idea. Time passes because information flows. So get this, it's saying time isn't just some passive backdrop, like a stage where events happen. No, time is the flow of information itself. It's not the stage, it is the play unfolding.
So what on earth does fractal time even mean? Well, instead of thinking of time as a smooth, straight line, like the hand on a clock, picture it more like a lightning bolt or the branches of a tree. It's a complex, branching pattern that actually archives the past. In this view, the universe has a memory. Seriously. Information about stuff that happened before isn't just gone, it's woven right into the fabric of space-time, and it actually influences what's happening right now.
Okay, so a universe with a memory? That's a cool idea, but how does it actually change the physics? Well, the theory doesn't try to replace Einstein's relativity, not at all. It describes itself as the engine under the hood. It's the underlying operating system that makes Einstein's universe tick.
And here is the absolute key difference. In our standard physics, gravity only cares about the mass that's here right now. But in the UCF theory, gravity also responds to the history of that mass. All that information that's been archived in fractal time, it creates an extra gravitational pull. The theory calls it a historicity term. And this extra gravity, it comes from the universe's memory, not from some invisible particle we can't find.
So how does this work? The mechanism is actually pretty elegant. As a galaxy lives its life, its entire history, all its mass and energy over billions of years gets encoded into this memory field. And then that field itself starts generating its own gravity, adding to the pull from the stars and gas we can see. So when astronomers see a galaxy spinning way too fast, UCF says we're not seeing the effects of dark matter. We're seeing the gravitational echo of that galaxy's entire past.
Okay, but look, a wild new idea is one thing. Being able to prove it is another. And the people behind UCF say their theory is designed to be broken. They call it Kruppstahl hardened, like crucible steel. It's forged for one purpose, to face experiments head-on, not to wiggle around the data.
And this is what's so crucial. The theory's predictions aren't based on a bunch of knobs you can twist and tune to fit the data. No, its core rules are dictated by a single, fundamental constant, the golden ratio, 0.618. The deep math is complicated, but basically, this number that pops up all over nature is also, according to UCF, what governs how the universe's memory pulls on things. And you can't change it. That makes the theory's predictions incredibly rigid. It either works or it doesn't.
And this brings us to the theory's biggest sales pitch, its elegance, or what scientists call parsimony. Think about it. Right now, we need one explanation for why galaxies spin too fast. That's dark matter. Then we need a totally separate explanation for why the universe's expansion is speeding up. That's dark energy. UCF says, forget that. It proposes one single unified framework. It takes the visible stuff we can see, the age of an object, plugs in its fixed constants, and bam, it predicts all of these different phenomena from just one set of rules.
All right, so this all brings us to the ultimate test. After explaining dark matter, the theory makes a very specific, very testable prediction about dark energy. And this prediction puts it on a direct collision course with our most powerful telescopes and our latest data.
And this is where it gets really, really exciting. The behavior of dark energy is summed up by a number scientists call W0. For years, the standard model just assumed this number was exactly -1, a constant. But recent hints from a huge sky survey called DC suggest that might be wrong. The value seems to be closer to -0.8. And here's the jaw-dropper. The UCF theory, based only on its internal unchangeable constants, independently predicted a value of, wait for it, about -0.794. That is a direct hit, a bullseye.
But it doesn't stop there. The theory goes even further. It doesn't just predict a different value for dark energy today, it predicts that this value should actually be changing over cosmic time.
And this is it. This is the key test, the moment of truth. Standard cosmology says dark energy is a constant, it never changes. UCF says, nope, it's thawing. It's evolving as the universe's memory builds up over billions of years. And this isn't some fuzzy, vague idea. It's a hard, falsifiable prediction. And the best part, our new generation of telescopes, especially the Euclid space mission, are powerful enough to see it. They can either confirm this thawing or rule the theory out completely. There's nowhere to hide.
So, we have a clear timeline for the verdict. A countdown is on. We've already had these incredible hints from the DESI data. But the final judgment? That's expected in late 2026, when the Euclid mission drops its first major data set. That data will be precise enough to settle the question, once and for all. Is dark energy constant, or is it thawing, just like this wild theory predicts?
And that leaves us with one last mind-bending thought. If this theory actually holds up, it means that for the last 100 years, we've basically been looking at the universe's user interface while completely missing its source code. It would mean our cosmos doesn't just run on the laws of physics as we know them, but on something much weirder and deeper: memory and information. We might just be on the verge of finally finding the universe's missing manual.